Okay, so we're talking about limits, okay? Alright, and limits, you have to be able to deal with the fact that a limit is something that you are approaching, but you're never really quite getting there. But you're getting so close that we essentially say that's what it is equal to. Okay? Remember reading about infinitesimals and whatever in that first little article maybe about calculus? That's the idea. Something so small we really can't distinguish between it and actually being at that value.
Like something smaller than a fork length.
Yeah. So a limit, okay, is going to be the value that a function approaches as x gets really close to a particular value. Okay? When you think of a limit, this is how you need to think. A limit is the value that a function approaches as x gets really close to a particular value.
Remember we had two bases and we had height. So we had base versus base over 2 times the height, right? So we have a base, right? Then we have another base, And you had what number 2? Times height. Well, we're not given height, so that's what we're trying to find. Multiply all that.
So here's an example of a type of limit problem you might see.
Yep, because that's our height. So we can give them just don't have the number, but we gotta find our x.
What this is saying
X alone.
is I want you to figure out what this function
Find what this number
is approaching, or what that function's value is equal to,
Okay, so the first
as the x values get really, really, really close to 2.
So how do we?
So in other words, the slope of point, or wherever the line is x equals 2.
On the number,
Oh,
on one side,
no,
yep.
okay, then mine.
Kind of.
No, we're not doing the slope formula, the f of x plus h minus f of x. We're not doing that, okay? We're just finding
Well, you still have that.
what does this function's value equal as our x values get close to 2.
We multiply basically
Okay?
multiply one.
Let me show you, for instance. I'll show you two ways.
Cancel
Okay?
that,
Oh,
right?
okay.
I'll show you with the table of values
14
first.
plus 22
Okay?
times
And this
what?
goes along with what we did at the start.
These.
Okay? If I make a little table of values, we'll call it x and then f of x here. Alright? We'll do 1.9,
Remember we
we'll do
multiplied?
1.99,
We took this whole
we'll do
thing,
1.999,
so really that-
and then we're also going to do
Yep.
2.001, 2.01.
And then
2.1.
this all is
Okay.
together.
We're going to use these values and plug those values in
36.
for x and see what we get for the value of the function.
Couldn't
Okay?
you first take an x minus 2 out of both?
Okay?
Or do you really not?
It's different to squares.
36x.
Yep.
You could simplify the function, yes. Okay?
Yep.
Yeah.
But I'm showing you,
Oh, just simply how to do it. not
yes.
this. Okay.
Yeah, I'm not worried about that right
What
now.
happens to
Okay?
these two 36s?
So, the reason I didn't just plug in a 2 is because, well, you can't.
Square 16
In this
divided
case.
by 36.
I mean, sometimes you'd be able to just plug in a 2 and, you know, if it's a continuous function, it'll hit that value. I'll talk about that once I get the graphs up there.
Well, it kind
Okay.
of be like where you couldn't really plug the H in until like the very end.
It's very similar. A lot of times. Sometimes you just can plug it in, yeah.
Okay.
Okay. So anyway,
It's okay.
we're trying to figure out what is the value of this function as we get really, really close to 2. So what I'm doing is I'm picking x values that are really, really close to 2 to see what the value of the function is approaching as we get close to 2. Okay? So just to save some time here, why don't you guys here do 1.9, you three in the back do 1.99, you two do 1.999, Zach do 2.001, okay? Why don't you guys do 2.01, and then you three do 2.1. Plug those in and then get your answers. Let me know. Just fill it out table of values.
So am I just doing?
How many decimal points do you do?
I'll probably ask for about 3 or 4 of them. Zach, did you get yours?
Yeah, but do you could be slightly off?
Hey, did you get like a small? Yeah. Two?
What did you get?
Yeah,
I got .2501.
I think you did it wrong.
Carbon .2501. And that was for which one?
0.996.
1.9.
Wait,
So 2.01
I
minus
think
2.
you have to put those in
I'm doing
front.
six.
Like all of that.
2506.
2506 for this one?
I figured it out, I got it right.
Way to go for it. Alright, for 1.9, I got .2564.
That was what you got?
Yeah, for .01 we got .2494.
I got .2499.
.2439.
Okay. So we fill out this table of values. Alright? Now, we should be able to get a pretty good idea what the value of this function would be as we get really, really close to 2. If we're getting closer and closer to 2, kind of from the left side, if you will, okay, so we're approaching 2 from below it. So when x was 1.9, we got this value. When x was 1.99, which is a little closer to 2, we got this value. When x was 1.999, we got this value, okay? So if you look, I mean, I was here, then I got here, then I got here. It looks to me like as I'm approaching 2 from below it, from the left side, it looks to me like the values are about getting equal to 0.25, right? Or getting close to 0.25. Okay? Well, let's look at it from the right. Okay? At 2.1, I was at 0.24. Then I got a little closer to 2. I got right here. Then I got even closer to 2, and I got right here. Does it look like that also is approaching 0.25?
Yes.
Okay? Based on our table of values, it looks to me like as we get really, really, really close to 2, the limit or the value of the function is approaching 0.25. As long as the value you are approaching from both the left side and the right side, and you guys understand what I mean when I say left side, right side, from below 2 and from above 2, okay? As long as those two things are approaching the same number, you can probably, with pretty good certainty, know that the limit of this function then, as x approaches 2, will equal 0.25. Again, you're making an approximation, but you're doing it based on the values you're seeing in that table. Okay? Because again, you're trying to figure out, okay, well, what does this function equal, or what is this function basically equivalent to as my x values get really, really, really close to 2. Okay, Ray.
So obviously in this one we can't just plug in 2 because that would make everything equal 0 and be
Undefined.
stupid. But will there be ones where you can just plug in the number yourself and you don't have to worry about
Very
it?
few of them, but yep, there are some easy ones just like that.
How do you know?
Okay?
Yeah, how would we be able to tell that we can do that?
By quick glance and see if a denominator would be 0. Obviously you can't do that then, like in this one. Square roots of negatives, you can never do that. That's pretty much it for the most part. Okay. Graphically, okay, I believe, I'm going to do a little algebra 2 here, advanced math here. Yeah, I think we're going to look something like if I were to graph this function, I believe, it's been a little bit, but I believe the graph would look something like this. Okay? If you recall from advanced math, if I factor the bottom, I got x plus 2, x minus 2, that's the difference of two squares. Because I have an x minus 2 and an x minus 2 in the top and the bottom, there will be a hole at x equals 2. Okay, so right out here at x equals 2, there'd be a hole. There'd also be a vertical asymptote over here at negative 2, because that's what makes the denominator 0. Okay, and really you're looking at this basic parent function for the most part. Okay, I'm going to see the graph of it. Graphically, okay, the limit as x approaches 2 of this function basically means, okay, take one finger, put it to the left of 2, take another finger, put it to the right of 2, and move both fingers towards 2. I mean, this is as layman as I can make it, okay? But I'm coming towards 2 from the left, I'm coming towards 2 from the right. Do both fingers end up meeting at essentially the same spot? Okay? And they do. So therefore the limit exists, and it exists at, you know, whatever y value your fingers ended up reaching. Yes, Luke?
But then wouldn't it always be at the holes in it?
Not if a graph looks like this. Okay?
Okay.
Piecewise. Now if it's a continuous graph, and I want to know the limit as x approaches right here, well, then all you'll have to do is you'll just have to plug in that value and figure out what the y value is at that given point.
So for the one above, would we basically try to do it as best we can, like what we did with the car thing?
If I asked you for the limit as x approaches, let's say that was 3 right there. The limit as x approaches 3, the limit does not exist. Because it doesn't approach the same value from both sides.
Gotcha.
And will we have ones like that?
Yes. Yep. Yep. I haven't gotten into the graphic ones yet, but I'm just trying to do one here first. But yeah, for a limit to exist, for you to be able to get an answer to this, your fingers have to be at the same spot. And here, they wouldn't.
Are there examples where it isn't one of those two options, like one that you wouldn't be able to figure out easily graphically?
In this one, if I asked you the limit as x approaches negative 2, would not exist.
Gotcha.
There's an asymptote there, one of them, and yeah, you're going different places. So
So anywhere where the two sides aren't going the same way, just no answer.
correct. Limit does not exist.
Right.
Correct. For a limit to exist, you must approach the same value from the left and the right. Okay? Just like in our table here. From the left and from the right, we were approaching 0.25. Okay? You will find limits today simply by doing tables of values and by looking at a graph. Okay? We'll get into more of an analytical or, you know, algebraic, if you will, way of solving them later on. Alright? So the table of values should be, fill out the table of values, make sure that as you're coming from the left and as you're coming from the right, or in this case bottom and top, okay, but that's approaching the value, make sure you're reaching the same number. If you're not reaching the same number, there is no limit. If you are reaching the same number, that number is your answer. That number is your limit. Okay? So you'll get some that are table of values, and then others you're just going to be given a picture. Alright? And I'll do a picture one here with you. Okay, let's say this is some crazy piecewise function, alright? If I asked you for the limit of this function as x approaches 2, you guys think
One,
your answer would be? What does it look like?
one-ish, maybe a little less.
Agree with that?
Why does he say that?
Well, x equals 2 would be right here, correct?
Yeah.
So if I'm following along here, all right, and I'm moving both fingers towards 2, it looks to me like they would meet about right here. What does it look like the value of the function is about right there? I would say 1. Okay? I'm guesstimating about where that would be. But I'm just doing this using the graph. Okay? So I would say the limit of this function as x approaches 2 would probably be 1. Okay, now it'll be easier to tell in your book because it'll probably be more on grid lines, a little better paper, all right, than just this whiteboard up here. Okay? What do you think the limit of this function is as x approaches 0?
It wouldn't be
No.
defined, or what's the
The
terminology?
limit does not exist, you're
Does
saying?
not exist.
Why does the limit not exist?
Because it skips.
Okay, it skips. As you approach 0 from the left, the value's getting close to what?
1,
1. As you approach 0 from the right,
2.
the value's getting close to 2. Those numbers are not the same, therefore the limit does not exist. You have to approach the same number from the left as you do from the right for that limit to exist. Okay? So, D&E works for me, does not exist.
JD.
Yeah.
We could use that this year again. Please say yes.
What'd you say?
Do what again this year?
Oh,
Put on every test, I don't care if it doesn't matter.
I did put it on every test.
Good.
Let's see.
your video's at 17 minutes. by the way.
17? Okay. We talked a little bit about it already. Let's say I add a little bit to this. An asymptote. 1, 2, 3, 4, 5. We've talked a little bit about it. I'll make sure it's on video and you see it. Okay. The limit of this function as x approaches 5 also would not exist, because as we approach 5 from the left, we're going towards positive infinity. As we approach 5 from the right, we're going towards negative infinity. Those don't match. So this would be another does not exist. Okay? So far, that's all we're really doing working with limits. We're going to use tables to help us determine what limits are, and we're going to use graphs to help us determine what tables are. Okay? Keep that in mind. Those are always options for you to find limits, even though eventually you're going to want to do most of them algebraically, because I think it takes less time. Okay? But I want to show you what it looks like. So, we'll go with that from there. I'll get your assignment here in a second. Actually, I'll just keep that in the video. Right there.
Sorry.
You're all right.
Always in the way.
Page 54, 1, 7, 9, 11. (15 through 23) odd and 25. Why wouldn't you just put 15 through 25 odd? I don't know. I'm putting 15 through 25 odd. Because that's the next odd number.
I didn't pick up on that.
Yeah, I was helping you out. See that?
I needed that.
I know. Okay? All right.